Thank you, guys, and thank you for attending tonight. As sort of briefly mentioned, this talk is very much in its alpha phase. So we're going to test and break the talk tonight, hopefully, and feel free to give whatever feedback you want, be as brutal and honest as you're happy with. I don't really care, so you just say what you want. So we're going to talk about test to break principles and why they're important. And the basic suggestion is why you should crash your car into a tree. So a bit about me before we begin. I'm Rob. I'm a developer. I've been coding for about 14 years. As the picture in the background suggests, I once wrote some code that got me on CNN, which was amazing and weird. I didn't hack anything, by the way. It was just something else. I've been a head of tech for 2.5 years, and currently I'm obsessing about RFC 7519, which is JSON Web Tokens. I have a little open source library that I work on. So if you're interested in that, feel free to grab me after this. Okay, so test to break. Obviously, if I told you to drive your car into a tree, you would think I was mad. That would be quite logical. No one wants to drive their car into a tree because they might hurt themselves, and fixing the car might cost a lot of money. But madness sometimes can be an issue of perspective. And if you work for someone like NCAP, which do the new car assessment program and test cars and test how they break cars, you might not see it as mad because your day job is to break cars. You drive cars into walls and you drive things into cars. Okay? So what this talk is about the same thing but for code. How do we break code, and why should we break code, and why is it important? It's also going to touch on what I've defined as the working software myth. There's a myth around working software which I think is important to raise and to discuss. And I'm also going to mention how test to break helps solve the ignorance complexity problem that we all as developers face on a daily basis. Okay? So to begin, there are 3 types of tests. Okay? And this is the first one. Anyone want to hazard a guess at what the first type of test is?
Standard software development load test.
Standard software development load test. That's very close. No, exactly. That's exactly the right answer. Round of applause for Dave, please. And the slide actually represents the RFC compliant Gherkin syntax for no tests. No tests is sadly one of the favorite types of tests that developers do. I have done it. I've even done it recently, like no tests. Not because I wanted to, but basically the code was so complicated I couldn't do anything else with it. But it happens, but it shouldn't happen. So that's the first type of test. Try and avoid this as much as possible, because if you just do no tests, you're going to write and build crappy software, essentially. That's what's going to be the output, unless you're some sort of genius, but very few of us are geniuses. So the second type of testing is what's called test to work. Okay? And this is basically answering the question, does the system work as expected with standard inputs? So we're basically writing some tests to see, and I assume everyone writes their tests first, don't they? Yeah, definitely. So we write some tests, and we're writing tests to prove that something works as we expect it with standard inputs. So tests might look like this. So we have, given the driver has a valid car key, when they insert the key into the ignition and they turn the key, then the car's engine starts. So we're just seeing if, like, we take a standard input, which is a key, a valid key, put it in, turn it, does it start? If it doesn't, we've got a problem. If it does, we've passed the test. The next one would be, given the driver has an invalid car key, when they insert the key into the ignition and they turn the key, the car's engine will not start. So basically, we've tested the car's ignition and engine just to see that it works as expected. Key is a standard input, okay? So that's the first type of testing, and that's really important type of testing. That's how you start building software, okay? And it's how you build, the beginnings of robust software, and they're useful tests for regression, which I'll discuss in a little bit. The second type of test, which is the one I'm here to talk about, is test to break. And this is asking slightly different questions, like, can the system be broken? And what happens to the system in unusual circumstances? Okay, so we're sort of stressing our system and asking difficult questions of it. And these sort of tests might look like something like this. So given the driver has a screwdriver, when they insert it into ignition and they turn the screwdriver, the car's engine will not start. So this is a test to see, can we break the system? Can we break the ignition system? Can we somehow hack it, break it, do something that's not meant to happen with it? It's a test to break. Another example is, given a car is traveling at 30 miles an hour, when it hits a tree, then all the seat belts tighten and the airbags deploy. This is putting your code or your car in an unusual situation, not a normal situation. Even though if you're driving on the M25, you think people are trying to kill each other all the time, like crashing cars is not something that people want to do, and it's not something that happens a lot. If you think about the number of car journeys that happen on a daily basis, the amount of crashes you have is very small. It's an unusual circumstance for it to occur. But people still test cars to see what happens when they do crash. Because obviously if the car drives into a wall and immediately explodes into flames, you have a slight problem there. That's not something we want to happen. We want something less killy and deadly to happen. So that's a sort of subtle difference between, it's not really a subtle difference, but it's a difference between test to work and test to break. And the issue here is that developers often focus on test to work, but sometimes forget to do test to break. And I'm here to sort of suggest that doing test to break will help you build better software. So we're now going to do a live code example, and I have never done a live code example before. So we're going to see how this goes, and this is just to sort of highlight how this works. So in terms of code, how we go from cars to code. Don't do it, yeah, absolutely, don't do it. So we've started, we're going to do a test with emails, because emails are nice and complicated, and you should get the picture quite quickly. So we've got some code. Can everyone see the code? Okay, cool. And we've got our command line, and I will boost that a bit, maybe. Nope, maybe not. This is one for feedback. Rob screwed up this command line. That's a, okay, let's see if we can boost that a bit. Okay, can everyone read that? Okay, cool. So we're going to go into email. Working, okay. And so we've got a bunch of little code set up. So I've already set a bit of boilerplate up, and we've got basic test. Obviously, we've followed test-driven development principles, and we've tested the class instantiation. Basically, this test is, we've got a simple email class, and we're going to add a validate method to it for testing emails. And it's just going to be a Boolean true-false thing, okay? So just going to uncomment the first test, which is test validate. So we create a new email instance, and then we're asserting true that when we call email validate with the email address rob.waller@test.com, comes back true, because that's a valid email. Yeah, very simple. So all we'll do with this is we go into our email class, and we're going to create a public method, public function validate, and this is going to return a bool. And if we're following TDD, we're just going to fulfill the test immediately. So we're going to say return true. Okay, so this should now work. And if we go to vendor bin, Oh, this is fun. Oh, it works. Right, so we've fulfilled the first test. So we've written our first test, and it's very simple. Test validate, and pass in an email. We've just set the function up to return true. Okay, so this is the first step of working software. The second test is going to be public function, and we're just going to do a test validate fail. So this is going to fail. Okay, so again, we'll just copy the code. And we'll turn the assert true to assert false, and we will change the email to rob.waller. So this is an invalid email, okay? We'll then quickly run our PHP unit again, and we get a failure, yeah? Because it's meant to return false, and it will always return true. So now we need to put a little bit of logic in to make this actually work. So we will go into our email, and we will do a preg match. And oh, you know what I did? I forgot to add the string email in the first time round. Proper schoolboy. Okay. And this preg match will return an integer, but we want a bool because we did declare strict types. Everyone here is using declare strict types, aren't they? Okay, good. So we're going to return a bool. We're going to cast that to a bool, and we're going to have a little bit of regex. Now, obviously, I'm going to cheat because I did this earlier in a sort of Blue Peter way, and our first regex that we're going to throw in is this, and all it will do is check that the string that is passed in, or the email, has an @ sign in it, okay? And if the gods of development are on my side, this should work. And it does, yay. So basically, at this point now, we've done 2 tests, and we've got a test true and a test false. And basically, we've solved email. We've got a working email validator. We passed in a valid email, and we passed in an invalid email, and they both work. At this point, we can go home for the day happy. If I was to run code coverage right now, we'd get 100% code coverage. Like, we've literally done everything a developer should do. You cannot criticize me or tell me I've done anything wrong at this point, because my code works perfectly. But obviously, that's not the case. And this is the point in your code, and obviously this is a slightly facetious example because it's just an email, and we know emails are monstrously complicated. But what we're doing now is we're going to write some tests to break. So we're going to ask some more difficult questions of our code. This is like the second round of testing. We've done our first round, we've got it working. Second round is, how do we screw with this? How do we break this? So we can write another test, and do not follow this naming convention for your tests. But I'm trying to do this as quickly as possible. So validate fail 2. Come up with something better than that, okay? Okay, so now we're going to do rob.waller @test, okay? So this now does have an @ sign in it, and it has something after the @ sign. It's not quite right. So this should return false, because we know this isn't a valid email. Someone who's an expert on domains will probably tell me I'm wrong right now, but who cares? This is not a valid email. So when we run this, we get a failure. It's meant to return false, but it actually returns true. Our regex isn't very good, okay? So we're then going to run another quick test just to double up a bit, just to make it difficult for ourselves, okay? And we're going to do fail 3. And this time, what we're going to do is we're going to do 2 @ signs. Do something slightly different. And this should hopefully generate 2 failures. So we've now got 2 failures. So we've broken our code and, messed around with it a bit. The way we get this passing is we do a slightly more complex regex. Which I also have prepared and have tested previously, I hope, and it will work perfectly. So we're going to swap over our regex quickly. And as we can see, we've got slightly more complicated regex. So this asks a few more things. It checks for characters, numbers, dots. It says that there has to only be one @ sign. Remember, our test had 2. And then we're going to check that we've got some characters and then at least 1 dot and then some more characters. So we're going to check for the @test test. Okay? Now, it passes. And what we've done here is, in a very silly way, just shown how, like, doing a few tests that attempt to break our software, we've slowly improved and caught some of the bugs in our code for email. Now, obviously, if you were trying to build an email validator this way with tests, it would take quite some time. You'd be writing a lot of tests and thinking through the tests. Probably best just to go on Stack Overflow and do a bit of copy and paste for email, or use Laravel or something. It's already built, hopefully, and hopefully, Taylor Otwell has tested his email validator. He's done the business on it, but whatever. So back to the talk. So that was our code example, and that showed like an approach where we started just writing some tests to work, to get something basically working, and then we wrote some tests to break that and make it better, okay? So why would we do this? Why would we bother with this? The issue is in software and development, there's a concept that I would refer to as the working software myth, okay? Which is that, working software is the only thing we should value. It's even in the Agile manifesto. Now, this isn't a critique of Agile. I have some of those critiques of Agile, but this isn't today a critique of Agile. Agile works for many people. But in the Agile manifesto, it says that we should value working software, and most developers are aiming for working software. But just because something is working doesn't mean it has value, okay? And we can see this on the slide. Essentially, what's behind the text is a working car. At some stage, that car worked. But who would actually want to drive it to work every day? In the UK, in the wet and the cold. And yes, I know that it's probably a very valuable car. It's probably worth a lot of money because there aren't many of them around anymore, the Model T. But no one would want to drive that to work on a daily basis. It's bad enough having to get up in a cold day and scrape the ice off your car. So imagine trying to get that actually started on a cold day. It'd be awful. So the idea that just because something's working, it has value is slightly flawed, and we need to come up with something better. Because ultimately, if all you're pursuing with your development is working software, I would say that what you're doing, your approach to development, is as follows. It's essentially Sex Panther development, or in other words, 60% of the time, it works every time, which is not like ideal, because users don't want it to only work 60% of the time. They want it to work all the time. Okay, but lots of people in the development industry are producing software that doesn't actually perform all the time. So we need a better aim than just purely working software. And you may disagree with what I'm about to say, but this is just an attempt at trying to articulate this. So I would say that our aim as developers is to produce code and products which function and are bug-free. And the reason for this is quite simple. It should function and it should be bug-free, because if it isn't functioning and it has lots of bugs in it, that will cost you money, okay? A lack of functioning software can drive inefficiencies in a business. It can slow the people in the business who use the software down tremendously, cut efficiency, and you'll lose money. And bugs might be the thing that stops the user buying a product off you, or staying on your website enough to engage with the adverts, or do something with your product. bugs will cost you money. People think that, oh my God, if I don't get the next feature out, I'm going to lose loads of money. When you produce a new feature for software, you have very little proof that the new feature is going to generate you any money. It's a shot in the dark often. Yes, you can do a bit of research and hopefully, yes, it will make you some money, but it might not make you money immediately. Bugs and non-functioning code will usually cost you money immediately. They'll immediately start hitting your bottom line. The only problem is you're in a slight Bastiat's window, sort of can't track the cost problem, but it's there. You will lose money. So we do test to break to basically improve our code to the point that it functions really well and it is as bug-free as humanly possible. Now, this is difficult to achieve, obviously, because at the heart of things, we have what is really the ignorance complexity problem that we all suffer from as developers. And this isn't something that just applies to developers. Thinkers have been thinking about this or philosophers have, for a very long time. So the man on the left is Socrates. And Socrates is almost like the first test-driven developer. Socrates came up with the Socratic Method, which was based around dialectics, which is basically trying to work out the truth of opinions. And the Socratic Method is basically a process where you ask questions of someone's opinions until you work out the truth of those opinions, or until you knock down those opinions and make them reassess their thinking. Essentially, you're asking questions of them, exactly the way you do with tests. You're asking tests of your code to see if it works and solve problems. Socrates was asking questions of people and trying to get the truth of things. Okay? And there's a famous story about Socrates, about the Oracle at Delphi. Basically, one of his friends went to the Oracle at Delphi and asked, who is the wisest man in all of Greece? And the Oracle came back and said, it's Socrates. So Chaerephon, who was Socrates' friend, went back to break this amazing news to Socrates about why he was the wisest man. And Socrates obviously pondered this and went and asked a bunch of people about whether he was or whether they were the wisest person of all. And what Socrates concluded was he was the only man, after questioning a bunch of other highly esteemed men, he was the only man who appreciated his own ignorance and understood that he was ignorant and didn't know everything. And basically, ignorance is often seen as a bad thing. It's thrown around on Twitter a lot. If you're on Twitter a lot, everyone's calling each other ignorant. You know, you're ignorant, you voted a certain way in Brexit, that sort of thing, happening all the time. But ignorance isn't actually a bad word, because we are all ignorant. You know, as developers, we don't know everything. Like, I don't know much about serverless, and I'm sure there are other topics that you guys don't know much about. We're all ignorant. It's just a natural state of things. But it means that we don't always know everything and we don't always know the answer to things. Okay, so that's one issue. The second issue is complexity. And the man on the right is a chap called Hayek. And Hayek is a famous economist in the 20th century, along with Keynes and Milton Friedman. And Hayek's rough theory was around the subject of central planning. And Hayek postulated that central planning, or societies that plan everything centrally, will generally fail. And the reason they will fail is because economies generate far too much information to process in a reasonable time frame. Like, you can't respond to issues in the market quick enough if you're centrally planning things, because there's just too much information. Essentially, what his warning was to economists and politicians was, the economy is more complex than you can ever imagine. So don't try and completely control it. Okay? And it's very similar with what we do as developers. The problems that we have to deal with on a daily basis are always more complicated than we imagine. There's always some sort of edge case that we haven't thought about. And ultimately, the situation we're in is ignorance is natural. Okay, we're all ignorant. And complexity is a standard part of our day job. Okay? And test to break helps this. And the reason test to break helps this, or solve this problem, is because when you test to break, you're asking interesting questions of your code where you don't know what the answer will be. And if you ask enough of these questions, you might actually pick out problems with your code that you never thought were there. You just have to come up with some interesting questions, like if I pass this string into the method, this method's set up to receive these 3 types of string. If I pass in a different string, what happens? And that's what test to break is doing. And you might get a random answer out that you can then fix. But if you do this, you get more robust software. So we're now going to do a second code example, which will go as well as the first one, which will be slightly more complex. So keeping on the car theme, basically, we're going to imagine we're building the website for the Model T. And there are lots of myths around the Model T, but we won't go into them. But we have some basic rules for our car factory and our ordering system. So the first rule is cars can only be black. This is myth number 1. Model Ts weren't only black, but there is a famous Ford quote about them being black. Cars can have 2 or 4 doors, okay? And cars must have 4 wheels. They're the rules, okay? And we're going to go through this example quickly, and then we'll be near the end. So, skipped ahead there. Saw my final slide, damn it. Right, okay, so we're going to open up this. So we have 2 things going on here. We have some car tests, which I've already written, for a car object. Very simple car object. It's got doors, wheels, color. And we inject those, and then we have some getters for just getting the information out. It does nothing more than that. Consume some information and get some information out. Already written some tests for it. And hopefully if we go in to that directory and we run vendor bin. So we've got some tests and they're already working. So we've built the car. Okay, so the important bit here is we're going to build the ordering system. And we've got a singular test going, which is just where we create a car object. We then inject the car into the order and we just assert that it's coming back with an order class. And order class here just sets a property to the car object that we inject. Okay, so if we remember our rules, a car can either be 2 or 4 doors, 4 wheels, and the color black. Those are the things it has to be. Okay, so if we look at our car test, no, our order test, we have the beginnings of a first test already done. So basically, all this is going to do is we're going to have a create method that creates the order in our system. And it generates a message that says, order created for a black car with 4 doors and 4 wheels. Okay? And we see we create a car with 4 doors and 4 wheels and the color black. Yeah? Okay, so obviously, if we save this, this is going to fail. So we get an error. Okay, it doesn't work, because we haven't got a create method. So we are going to very quickly create this public function create method. We don't have to pass anything in, and we're going to return a string. Okay. And we're just going to return the string that's in the test to begin with. So we're going to return this string, just to get it working. Okay, and if we just do that, it starts working. Okay, so, but we had a secondary rule here, which was that we could have 2 doors, not just 4. So we're going to create a second test for our order test. And because it's easy, we're going to give it a slightly better name. So we're going to say 2-door. Okay? Really moving forward with this stuff. Just check our car object. So the doors is the first variable. So we're going to pass in 2, and then we're going to have change our test slightly to two doors. Okay, now if we run this, obviously it will fail. Okay, so it's failed. So we're going to make some minor edits to this code. We're just going to concatenate some strings quickly. So we're going to do car get color, spelt the English way, I believe. And we're going to do this car. Yes, yes, I made my first mistake and someone helped me out. Brilliant. You should have let me embarrass myself when I ran the test. Come on, guys. I'm trying to break this talk. And then we're going to do another one. Do some copy and paste. God, if I had like 40 people looking at me every time I write code at work, I would produce so much code so much faster. So get doors. And then we're going to do just get wheels, okay? And if we do this, we've done this properly, it works, yes, almost first time with only a minor intervention, okay? Obviously, we've gone over my 80 character line, so that will get picked up by sort of syntax testing or linting. But one thing to mention here, which is a little tip, which hopefully you can go away with and use, PHP unit, there's a difference between assert equals and assert same. You should use assert same because it checks value and type. Assert equals only checks value, which is old school PHP. Leave that behind. Assert same. Hopefully that will be the positive feedback for today. I've taught you that, if you didn't know it. So basically, we've now done test create order two doors, okay? And you know we've essentially got this code working. So this code now works. And we could deploy it to production. It's got 100% code coverage. Everything works okay. And if we only had one ordering website, so if we imagine the Ford factories in the US to begin with, they're only selling the Model T in the US initially, everything's fine. Because all we do is we pass in our variables and nothing goes wrong. Okay? We understand the environment, we understand everything. But this isn't how the real world works. So we don't actually have to change the rules of the system to start having problems with this code. Okay? This test to work code. Imagine that the people at Ford decide, oh, well, we're going to expand globally. We're going to build a factory in the UK and we're going to build a factory in Australia. And then we're going to start allowing other companies to start selling our cars online. And all they have to do is we'll create them an endpoint and we'll use this ordering system and they can start inputting their data. Same rules. You can have 2 or 4 doors, you can have a color black car, and you have to have 4 wheels. Same rules. But how many of us trust other developers to follow the rules that we lay down perfectly? Imagine like 30 companies decide to integrate with this system. After a while, you're going to start getting orders through for order created for a block car or block colored car with 3 doors and 8 wheels. That will happen. We know that's happened because that's how users use things. And going back to email tests, we know the users won't always type in the right email. And it's the same with this sort of situation. People will start passing information through that breaks our system. And there's been no rule change or anything. It's the same rules. It's just that people will start breaking it. If we expand it enough, if there's enough variables, it will start to break. And then that will have financial consequences. Imagine you're a car company and your factory's getting all these random orders for 8-wheeled Model T cars, and then customers down the line aren't getting their cars because there are delays and you've got to employ customer service people to handle this. You've just generated a hole and started throwing money in it and burning it. And ultimately, if we just had taken a bit more time with this code rather than 2 minutes and written some further tests, we could have imposed these rules like very strongly. So we could set some rules where we do something along these lines. So we're going to do test to create order fail. And what we're going to do is we're just going to do a little annotation on this and say expected exception. So we're going to expect this test to throw an exception, okay? PHP unit annotations are really useful, really helpful. And we're just going to change our code slightly. So we're just going to do this. And because we're expecting exception, we don't have to do an assert. We just do order, create, and we're going to change the doors to 5, which isn't part of our rules. You can have 2 or 4, okay? And basically, this is a sort of test that will go, okay, well, it has to be 2 or 4. If we get 5 or another number, we're going to expect an exception. So someone can't use our code in the wrong way. And we can start doing that with everything else. So we can say blue instead of fail 2, obviously, blue. And we'll set this correctly. So that is 2. So now we're imposing the black check like very strongly. And we're saying you can only be black. There's no situation it will throw an exception if you try and use any other color. And this way we get much, much more robust software that will work. Now you could say why bother, because obviously, you know, if we get to the point in time where we need to expand, our clever developers will think about this and go, oh, the code's not ready for expanding. But that never happens. And also, you've got to remember, if we went back to our order class here and added in an if statement just to catch that and throw an exception if it wasn't right, if the car object wasn't right, we throw an exception, that's far cheaper and easier to do than have like a customer service team dealing with a whole bunch of wrong orders and having a whole bunch of pissed off customers. Does that make sense? Okay. So that is roughly the end of my talk. And we get, I hit the tree, smiley face, I crashed the car into the tree. And the basic review point here is that, like test to break, the aim of it and the reason you should do it is because it's to build more robust software. Mainly because you don't have all the answers to everything, not because you're stupid, just because none of us do. And the systems we're dealing with are complex. So you should write some tests, get something working, and then you should start asking difficult questions of your code. What happens if this? And maybe get a few people involved in that process. Maybe as part of a code review. Hand over your test to someone else and go, can you think of some other tests that could write that might break this? Or might put this code in an unusual situation and might generate a weird outcome. And if you can do that, your code will be much more robust. Okay? That's me. Thank you.
Yeah, I've got a question. How do you know when the process of finding failure cases is done?
I mean, that's an impossible question to answer. You'll never know that. Really, all I'm saying is that you should do some of this because you're not going to find every single bug. You know, some of the best resourced companies in the world can't find every bug. I'm going to say Microsoft and various others, but you know, companies with enormous resources can't find all the bugs, and you know, so I'm not expecting you. What we're trying to do here is really try and get to the point where the only bugs you have in a system are odd edge cases. The problem I see time and again in development teams and in software is that a lot of the bugs are not really edge cases. if a little bit of thinking had gone into it, you could have probably found that bug before it reached production. So really, test to break is just a way to try and minimize bugs as best as possible and build more robust software.
Question, got a couple of parts. Excuse me while I ramble. You said you seem to be implying that TDD was a good thing. Is that correct?
Yes.
Do you think that the people who write code will always have the right set of skills to find error cases? Or do you think it's going to be a case where it's a completely different skill set required to one skill set making stuff work, another skill set finding error cases to write these types of tests for?
There might be some truth in that, but I think most people could find some errors in their code or be good at it if they thought about it. Obviously, not all teams are perfectly resourced. Some teams have a lot of junior developers, but this is something that definitely I feel needs to be thought about, because you do see a lot of 101 errors that could be caught. And I think if people thought about breaking their software more, they might capture some of those problems, those headaches that waste a lot of people's time, resource, and money, basically. I don't know if that answers your question.
What code got you on CNN?
What code got me on CNN? Okay, that's a different question. Many years ago, I wrote a bit of code that did fake follower analysis on Twitter. This was in 2012, and some journalists were looking into people buying fake followers. And I'd been in the email marketing industry, spamming people, Pizza Express and stuff, that sort of good old email marketing or spam. And basically I thought, well, the principle of list cleaning email is the same as list cleaning in Twitter for your followers. So I thought, oh, right, quick algorithm, did it over a weekend, put it live and sent it to one or two of the journalists who were looking into it. Didn't think anything of it. Few people used it, and then one day someone at Mashable wrote an article about Romney versus Obama and did fake followers comparison for Romney versus Obama, and then everything went completely mental. I was on shared hosting at the time for this little algorithm. It fell over immediately. I went from like 3 hits a day to 30,000 an hour. It was mental. So yeah, and then I got on CNN and all sorts. It's crazy. Definitely not. I was a complete idiot back then. This is all based on experience that this stuff helps, basically. I would now, yeah, God. But then I might not have finished it in a weekend and got on Mashable and what have you. But anyway.
I wonder, so this topic seems to be linked to mutation testing. Have you used any of that? Does that work?
I have used mutation testing. It is a very complicated topic, and I haven't got my head around it yet. But because I ran some mutation testings on an open source library I developed, and then sent it to the guy who created PHP Mutant, is it? Or there is one. There is a mutant testing tool now. It needs Xdebug, and he said I had a good score. I don't know why I had a good score, but he told me I had a good score. So yeah, there probably is some connection to that, and mutation testing would probably help, yeah.
Cool. Thanks very much.